Here we have standard Platinum GameCube and a couple of basic tools. We've got a screwdriver and a clear Bic pen. What I'm going to show you is some tips on installing a GameCube mod chip and tweaking your laser. If you did a soft mod, you might notice that some of the discs don't read properly, so you might have to do a laser adjustment. I'll show you how to get into the GameCube and adjust that. So anyway, the GameCube actually has these proprietary screws. Now, if you're not going to actually buy a mod chip and you did a soft mod, you're going to have to figure out how to take the screws out. The number one method is, it's called the pen method. You go get a clear Bic pen, remove the ink, and with a lighter or over your stove, you heat up the tip of this, go into your cube, while it's still hot and gooey, mash it all the way into the bottom and let it set. After a couple of seconds, the plastic will harden around the screw and you can use this to pull the screws out. You'll have to keep heating the pen up every single time you want to do a new screw. Don't let the pen heat up too much or set on fire, and try not to catch the pen on the sides of the shaft, because if you get molten plastic in there, it's really hard to get it out. Okay? I already took the screws out and I replaced it with standard. These are everyday screws. I don't know where I got them. They were just laying in my parts bin. Okay? Once you take the screws out, it's just a matter of many layers inside the cube. Right here is my GameCube mod chip. This is a Viper GameCube regular. There's also the Viper GameCube Extreme chip. This is, I think it has 128K of memory. Relatively basic. Okay. The first thing I'm going to do is I'm going to remove my chip. Okay. And we are going to start getting into the core of the cube. You've got two little clips right here. Let me turn this around for you. Two little clips here and here that are used for removing the controllers. Got to take my cards out. And this hinges forward. Okay? You'll notice there's screws here, 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 here. Got one here, one here, one here, one here, 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 and here. Okay? Standard Phillips head screwdriver. Start taking them apart. Okay, now we've removed the fan. Remove the fan, the main power switch. This is the main from the power supply. Pretend this isn't here, because this is all from my mod chip, which I'll explain later. You can just put a little bit of pressure and pull this out. Be very careful not to put pressure on these pins over here. If this cable rips, you'll have no controllers. Here's your reset button right here. Here's your CMOS battery for your BIOS, and here's all the connectors for your GameCube controllers. Put that aside. Now you'll notice that once you take this panel off, there's going to be some screws over here. Just take those out, and you might want to take off the lid sensor switch. Once you take the fan off, you'll notice that there's 3 more screws over here. Remember how all of these screws go in, because if you don't remember, in the end you're going to wind up forgetting to put screws in, or you put them in the wrong order, and the console will not go back together properly. When dealing with the lid sensor over here, be very, very careful on these wires. They're very fragile, and if you break them, then you're going to be screwed. Don't break them. Okay. Once you take all the screws out, lift straight up on the optical drive. It should come right out. Okay? This is where the GameCube mod chip is installed. You actually have to take the heatsink to the CPU and the GPU off and install one wire. Now, one wire, it's on a pad that's comparable to one of these. I'll use my camera, I'll zoom in a little bit and see if I can get a nice accurate shot of all these connections. Okay, those are all the connections. They're fairly easy. As you notice, they're all pre-tinned. And if you see the, let me use one of my multimeter probes here. If you notice that these wires here, there's actually a chip underneath here with a solder point roughly this big. So if you don't think you can solder onto something that's this size, I would recommend you don't try this. To be honest, as long as you have a steady hand, it's fairly easy. You really shouldn't have anything to worry about. Alright, here's the laser assembly. Yay. We're going to need multimeter. If you notice, there's a couple of screws around here. Of course, take them off. Now take the heat shielding off and the RF shielding, and you will notice a very, 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 very tiny potentiometer right here. Here is the potentiometer, also known as VR40. You're going to need a multimeter, an ohm meter to be precise. Normally, this will come between 170 to 310 ohms in resistance. You want it to be somewhere between, I would say, 160 to 210. Now, you'll have to put one probe on the single lead, and then there'll be a mark right here that says VR40. I doubt you can actually see it after the encode of this video, but use this as your reference on the other leg that you actually have to test. I'll turn my multimeter on real quick, and I'll get a current reading of my resistance. Okay, put one here, one here. Mine's reading 208, 207.4, roughly. About between 200, it's fluxing around between 206 and 207. Okay, when you adjust this, okay, look at the size of my finger. Look at the size of the tip of this pen in comparison to this potentiometer. It is very small. So you're going to need a very, very small screwdriver to make this adjustment. Even just tapping on this will actually adjust its value. So be very, very, very careful. I'm going to go ahead off camera and I'm going to adjust mine closer to, say, 195, maybe 190. And then I'm going to go and put my cube back together and test to see if it's booting other discs. If your ranges are too out of whack, you'll be putting a little bit too much stress on your laser and run the risk of actually burning it out or wearing it down faster. So, you've been warned. The GameCube is nearly all together. All I have to do now is put the controller ports back in. But I wanted to show you my GameCube mod chip, also known as the Viper GameCube. This is one of the earlier revisions. It doesn't have all too much memory, and it's got a lot of features and a lot of benefits. Some of those are customizable BIOSes, different bootloaders, has a built-in action replay cheat code functionality, and I love it. I'd love to get the Viper Extreme soon and show you guys that one, but in due time. When you install the chip, there's a small little piece of the shielding right over here. They're supposed to be bent upwards. I just broke it off. And this is the connector. These actually interface into the, these wires right here actually interface into the GameCube's system bus. These wires over here lead all the way around to the lid sensor switch right here. That way you can actually go into this chip and to the settings, and if you don't have a custom GameCube case, which is something I forgot to show you, this case actually supports full-size discs. So if you actually plan on using the original GameCube case and you want to put in original discs, the original discs only take up about to here, but original backups or DVD-ROMs will actually be out to here. You know what? Here we go. There you go. This will not fit in a standard GameCube case. Yes, you can take a standard GameCube case and take a cutting tool and cut all this out, but I think that destroys all resale value, and you lose the eject button. You can no longer eject the lid. You'll have to go and use some kind of Velcro or something. This case, this alternate case right here, only cost about $20. It was a very cheap run-of-the-mill brand. It actually came with a sticker that you could put over here to replicate the Nintendo logo or your own custom, and even give you one where you can print out your own custom logo. Of course, if you're going to go out and buy a chip, also buy the case. And if you're going to buy the case, you might, a lot of people are into modding and pimping out their stuff, so that could also be a possibility for you. Translucent cases, chrome cases, whatever. Okay, I'm going to finish putting my cube together and wrap it up. When the GameCube powers up, it's going to try to load an external drive code, which allows enhanced disk read compatibility. And then it's going to boot into the main boot menu. The first thing you can do is either a direct disk boot, so if you have a valid GameCube game or homebrew in there, you can boot it up. You can boot the original BIOS, or you can enter the configuration menu. Inside the configuration menu, you can set the display mode. I've forced mine to set always as NTSC. Now, the good thing about having a chip in your cube is that you can actually play games from not your region. So there are a lot of really nice collector edition games that are in PAL-only format that normally would not load in my cube. The default boot action, which in my case I've set it to the main menu, you can change this to automatically go to the GameCube BIOS or automatically boot your game. Holding the X key when you turn on your cube will perform this said action. For me, I told it to go to the original BIOS. The lid sensor pass-through. This is used if you have a GameCube case that has actually been removed because you can't fit original discs in, or for some reason that your lid sensor is not functioning properly. Now, since I have a chip inside of mine, this allows me to tie the chip in with this sensor, and that's with the pass-through device. I can also set this to override if the system is disassembled or not. That'll actually pose problems with Action Replay and other multi-disc games, because if you put it through always closed, it won't detect that you've opened the lid. The built-in audio stream fix is very important because some games actually use streaming audio. And if you don't have the built-in audio stream fix, then the audio will come up as static or noise, and it'll just ruin your gameplay experience. The drive code selection. Now, as I've explained earlier very briefly, that the drive code is actually the firmware or the drive loader firmware that loads on your actual optical drive. By using an external drive loader code, or drive code, this will enhance compatibility with disk reading. So typically the original optical drive of the GameCube is specifically coded to read GameCube discs to improve compatibility with GameCube discs. Now, using an external drive code widens that compatibility. So although the GameCube drive is very bitchy and very picky about what media it can read or cannot read, this will widen the spectrum of the different types of media you can read. You can also check the version information of your console, which, yay, big freaking whoop-de-doo. The Disk Explorer is just that. It is just an Explorer. Now, I have actually recently upgraded to the Viper Extreme chip, so you might not see the Explore Flash file system. The Viper GameCube Extreme, in fact, has, I do believe, 16 megs of onboard flash file system, which means you can actually put DAL files and other executable homebrew on the actual chip itself. Otherwise, you'll just be stuck with the Explore Disk function, which will let you explore the data that's on the disk. The Cobra also has a built-in cheat code system, which I really like. It's native to Action Replay, so if you're familiar with Action Replay, then you can use the Action Replay system. You can actually load the codes through the actual Explorer menu. You have to have the codes set on the disk in a specific way. I'm not going to explain. It's in the README of the cheat system. The change disk function is just that. It allows you to change the disk. Because the drive is always and constantly spinning the disk, you can't just open the lid or grab the disk and pull it out. You have to hit the change disk button to allow changing of the disks. The plugin. Now, the Cobra BIOS as well as the Viper GameCube and GameCube Extreme allows you to assign inside the BIOS a .dol file that will allow you to run it as a plug-in extension. Now, you can set this to practically any DOL file, an NES emulator, a Game Ripper. I use SD Load personally. That way, I can just put in my GameCube adapter that I made, the memory adapter that I made in the GameCube soft mod segment, and load SD Load from my chip instead of loading it from Action Replay. These are some of the basic features of the Cobra BIOS that has been put on my Viper GameCube mod chip. There are also other mod chips out there, but these are just some of the basic features to look for.
Hey everybody, I'm Dortz, and this is the BSOD Conditionals and Loops tutorial. Today I'm going to cover if statements and for while loops, along with Boolean values. So, here we already know what's going on, but here is a Boolean value. Now the thing with the Boolean value is you can only have it be true or false. That's why it's sometimes called a Boolean flag. You'll hear me mention it as a Boolean flag from here on in. So here we don't have it set to anything, but once we hit our main function, I assign it true. That's how you do it. You can either assign it true or false. And next we have a while loop. Now syntax for a while loop is just while, parentheses, and in those parentheses is a conditional statement, which I'll be covering in a minute. But for now, we just have running. So while is going to evaluate to running, which is true. So while it is true, it's going to do everything within its brackets, which is basically the whole program. We do this to allow it to loop back if the user wants to run through the program again, basically. So while running true, it's going to run everything in here. If running evaluates to false, it's going to break the loop and skip all this and go to the end and move on. But running is true, we're going to run everything in the brackets. So we have some output and some user input, and then an if statement. Now here we have the if statements work with conditionals. Conditional statements: greater than, less than, equal to, not equal to, or an and. The or and are for complex conditional statements. Not equal to is if something is not equal to something else. This equal sign, note it's the double equal sign, because we've already used an equal sign as the assignment character. Duh. So greater than, equal, or less than, I hope we know already. So we have a test case. This one reads if val is greater than 4 or val is less than 4. So that's going to evaluate it to either true or false. We have this expanded out so you can see it a little better to demonstrate if and else. So if val is greater than 4, so if this is true, it's going to do this. Else, which means this is false, it's going to move on to this, which else I have another if statement if val is less than 4. So if val is, say, 3, this is going to be false. This will be true, it'll run this. So if val is equal to 4, it's going to not be greater than 4, it's going to not be less than 4, it's going to hit this one, because it's greater than, less than, it has to be equal to. Now this statement is of course redundant for those of you paying attention, because if it's even going to reach here, val has to be equal to 4. But I just put it in there to demonstrate how the equal to syntax is used. And also I have these brackets here, which kind of useless because I only have one statement, but it also points out that you can have an if statement where you can do 100 different things in it as long as it's within these brackets. So if val is equal to 4, it'll do everything within the brackets. Next I'm going to cover a for loop. Now for loops seem a little bit complex, but they're somewhat easy to understand. So the syntax for it is for, parentheses, variable, condition, iterator. So here we have I is equal to 0. And we had to declare I. You can use a previously declared variable, but just for good coding practice, I like to use I, and you want to actually create it in the for loop. And then the conditional statement, I is less than 10. No, I is equal to 0, so this will be true for the first condition. And then this, I++, which is an iterator. The I++ statement is simply I equals I plus 1. So the first thing it does is it'll create the variable, then it's going to evaluate this statement, and if it's true, it will run this, which is, oh, how I love to count, and it's going to spit out I, which the first time it runs it will be 0, and then it's going to hit the iterator, so I now equals 1, and it's going to go to here again, because it's already made the variable and initialized it. So it hits the conditional statement again, I is 1, which is less than 10, so that evaluates to true, and hits the loop again. So now I love to count, and I is 1. And then it's going to keep going until 9, which will be the last time it hits it, because 9 less than 10, it'll hit the loop. And then it's going to iterate I is equal to 10, which is not less than 10, obviously. So it's going to break the loop, skip this, not iterate again, and move on. Next we have a switch statement, which does seem horribly complicated, and you're thinking, why would I ever use this? But it's very useful for setting up menus and just stepping back and taking a look at it and knowing where things are going instead of having 18 million if-else statements all jumbled up together. So here we have the user enter a value between 1 and 5, and a switch statement, which is switch, parentheses, variable name, open brackets, and all these, case and break. So in the case that the user enters a 1, colon, it's going to do stuff, and then it's going to break the statement, which breaks the switch and moves on. If it's 2, does that, breaks the statement. And you see the syntax here. We don't have a bunch of parentheses and brackets and everything going on. It's just open, very visible, very easy to understand. Here we have the default statement, which is if none of these cases are true, it's going to hit default, and usually you'll want to just spit out something to the user to tell them that they've made an incorrect output, and possibly it'll loop back to the beginning of the input again. But here, we're not going to worry too much about it because this isn't like a full menu. So don't forget to close the brackets after your switch statement. And there you go. So now we have the user enter 0 to exit or a positive integer to go again. So if our val is equal to 0, running is now set to false. Otherwise, we'll keep running set to true. And here it's just good coding practice to always make sure that your Boolean values are set to what you want them to be. But if we didn't notice, this is redundant as well. But good coding practice. So if the user enters a 1, it's going to go back to the top. While running, which is true, it's going to run all this code again. But if we set it to false, the while loop will break because it'll evaluate to false, and it'll hit return 0 and end the program. So that's it for the coding side. let's go over to the compiler side and see what happens. So here we are on the compiler end of things. I've already taken the liberty of compiling and saving our executable as BSOD. So I'm going to run that real quick and we'll see what we've got. So first we have the value to be evaluated by the if statements. Remember we were banking off of 4. So I'm going to enter 4, which is going to first evaluate that it is not greater than 4. Then it's going to evaluate that it's not less than 4. So it's going to hit that final else statement, evaluate that it is equal to 4, and spit out which is equal to 4. So then the for loop happens, and like I said, it's going to start at 0. It's going to do its evaluation of the conditional statement, and it's going to spit out, oh, how I love to count, and then I, which at that point is 0. Then it's going to iterate the I++ statement, and then it's going to evaluate one more time where I is equal to 1, which is less than 10, spit out, oh, I love to count, and then I, which is now 1, iterate again, and so forth. It's going to keep going until 9, which is the last time it's going to do that, and then iterate one more time until it's 10. When it evaluates the conditional statement, it will evaluate to false and break the for loop. So now we're here to enter the value between 1 and 5 for the switch statement, and let's do 5, which is one of the valid cases for the switch statement. So it brings us through there after it evaluated, and now to our setting the Boolean flag. So we have a positive integer, and that's going to make sure the Boolean flag is set to true. Loop back, hit the while loop. The while loop will again evaluate to true, and it'll run through everything again. And here I'll put in a invalid value for our switch statement. So now it evaluates through all of the cases. All of the cases are false, and then it hits the default statement, which is loser, learn to count. So now we're back at here, 0 to exit, and there we go. That was your tutorial on conditional statements and loops. I hope you enjoyed it. If you have any questions, you can go ahead and hit me up on the IRC channel or the BSOD forums. And this code, as well as some sample code, will be up on the show notes. And I'll see you guys next time.
Well, today I'm going to show you different power sources. Right now, we're at McDonald's, your average American classy restaurant that provides high-speed internet access, but they don't provide any place to plug in. I haven't found a power outlet here anywhere in the restaurant. So I got all these different ways to show to connect, but I'll show them later because we're probably going to get thrown out of here. But the two main things you need today is this is a screw-in socket. You screw it into a light socket, and it gives you basically a 110 volt outlet. Only problem is your average laptop connector is grounded, and this is only 2 pin. Get this at the dollar store. Get one of these at the dollar store on this side. See, it's 3 holes. Shut up, kids, I'm recording. Ignore that. Anyway, on the other side, it's 2. I'm sure you've used these before. Just plug this into here. It's a little tight. Find the adapter for the laptop. Plug it in wherever the hell that goes. Okay. Now, what you want to do, hopefully when nobody's looking, is as you see, there's a light outlet above us. I previously loosened up the light bulb so it would be cool and I wouldn't burn the shit out of myself on video. Basically, unscrew this light bulb. Just ditch it somewhere when nobody's looking. Screw that in. Now we got power to our laptop. And voila.
now we can sit here all day enjoying leeching their Wi-Fi. Why did that just make the shutdown sound? Well, anyway, I'm having technical difficulties, but another thing that is good to keep in your laptop bag. I got this with my Pocket PC. It works for pretty much any USB charge device. Plug this into your cigarette lighter adapter in your car. Now you got a USB port on the back that provides, what's it, like 5.3 volts? Whatever, I think it's 5.3 volts or something like that, whatever the USB standard power is. But you can plug any device into here, a cell phone, Pocket PC, anything that charges via USB. I also got one of these, plug it into a 110 volt outlet. Again, you can plug anything into it like that. When you're in this situation, you can only plug one thing into the light socket, right? Say I want to charge my Pocket PC. Get a USB sync charger here. Just plug it into the side of the laptop. Plug it into the Pocket PC. Now we got two items charging off of that. Great for new Motorola phones. Mini USB to standard USB cable. Plug it into the laptop. Plug it into the bottom of your cell phone. Charging my cell phone off of that also. Always good to bring an extra battery. Laptop batteries are kind of expensive, so try to obtain one somehow cheaply. Cell phone battery, always good to bring an extra cell phone battery or two because newer laptops, I had a PCMCIA Edge card for my old laptop, but they gave me this new uber powerful thing that doesn't do anything I want and does everything that I don't want it to do. And they did away with the PCMCIA slot, so now I got this remote control shoved in here, which who the hell needs a remote control for your laptop? I mean, it's a friggin' laptop. It sits on your lap. Do you need a remote control? But anyway, I can't plug in my card anymore, so I have to tether through the cell phone to get on the internet most of the time, and that really eats the cell phone battery. So that's why it's a good idea to have this cable so that you can charge your laptop, charge your cell phone while you're on the go also. Another thing I wanted to show you is I got a cheap power inverter. Unfortunately, I forgot to bring it with me. Hopefully I'll cut in to another video that I shoot later to show you that. But it was like, I think it was like $19.99. I got it at Walgreens or some drugstore. It's just a 100-watt simple power inverter. One plug. You plug it into the cigarette lighter plug your laptop into that, and now you can charge when you're in the car. The bad side to that is, like I said, it's only 100 watts, and laptops are anywhere from 60 to 90 watts. If you got a laptop that's a whore like Fox's old one, it'll use more than your desktop. So you might not be able to run something like that off a power inverter. What would be great is you can get a DC charger for the laptop. So that way you're not having to step it up to 110 volts or 120 volts and then back down to the 12 or 15, whatever your laptop takes. But all these different solutions, they're just suggestions. You'll have to find your own way. But I forgot, in the wintertime, another good thing. By the way, this works in public light sockets too, anywhere you go. You're in front of somebody's house, plug into theirs. But around Christmas time, the holiday times, or sometimes even lazy people just don't take their shit down. Christmas lights. There's usually always a little 110 volt socket on the end of that. So, there again, you need your 2 to 3 prong adapter because there are only 2 prongs. Plug into the end of that. Trust me, it's always on. Whether the lights are blinking on and off, your laptop's not going to blink on and off. They send constant current to that plug on the end, so don't worry about that. It would be kind of cool, but so plug in the Christmas lights and while you're capturing people's credit card numbers, stealing their electricity. Yeah. Anyway, don't do that. Hope you enjoyed this segment. Hopefully I'll have more tips in the show notes. If not, fuck off.
In this segment, I'm going to show you how to modify a PCMCA Wi-Fi card so it has an antenna jack. Now, this is a part of a series of 2.4 gigahertz mods, and this will be one of the two final products that you're going to wind up with. But before we begin, I want to explain something. Here in the United States, we're actually, we have something called the FCC, or the Federal Communications Commission, or some shit like that. Shit, I'm even licensed by them. I don't even know what they're called. There's FCC ID numbers on these cards. It doesn't matter if you live in the United States, United Kingdom, wherever. You can go to fcc.gov, take the FCC ID number of a Wi-Fi card, and get internal photos of that card. Very helpful for looking inside the card before you even buy it, if you can get the FCC ID number. And this is a primary tool that I personally use in selecting moddable cards. So we're going to go to the computer side, and I'm going to show you going across the FCC's website with a valid FCC ID number to get internal photos and how to determine whether or not a card is moddable. The first thing you want to do is go ahead to fcc.gov in your favorite browser. At the top, you'll notice a link to search. Go ahead and click that. Scroll down the page quite a bit, and you will notice a link that's for the FCC ID number search. Go ahead and click that link, and you'll notice that there's a whole bunch of information that you can search by. Now, this is just like any other search engine. If you give it the wrong information or incorrect information or too much information, it won't work properly. But for the sake, let's just use Kosher Pigs card, which starts with RAX WN4301C, and we're going to go ahead and search that FCC ID number. Lo and behold, we've got some results, and if you look at the upper and lower frequency coverage, which this is also good to find out what frequency a radio device uses, you can go ahead to the display exhibits on the left hand side and click detail. It's going to give you some warning saying that we're not responsible for misinformation, who cares, whatever. And here's a whole bunch of PDF files, which you're going to need a PDF viewer. Of course, my choice is Foxit PDF viewer. You're going to have a whole bunch of information. We are interested on the internal photos. So we're going to go ahead and open that up in Foxit. And here's the internal photos. Fun stuff. Really groovy. Here, I'll explain some of the components that you'll see in here. Over here is one of the antennas, and over here is another one of the antennas. This big silver thing, that is a radio frequency shield. That's where all the radio frequency circuitry is held. Now, these tracks leading outside to the antennas, those are your signal wires. If you notice, let's zoom in a bit. This component right here, which is usually a capacitor, I could be wrong in some cases, could be an inductor, or even a resistor. This routes it to the actual antenna. See, there's one down here as well. Now, there are pads on the board, one here and one here, that are used for actually soldering in some kind of, let's say, RF cable, like some coax, so you can put an external antenna. Now, this is the internal photos of Kosher Pigs card. And if you look down a little bit more, you can even see the insides of the RF box, which is pretty cool because it shows us that it's using an Atheros chipset. Very good information if you need to run Linux. Okay, so let's go ahead and punch in Mustang's card information. Whoop. Okay, do a little bit of searching. And we're going to go to the detail again. And we're going to look for the internal photos. And here's the internal photos of Mustang's card. Let's scroll down a little bit and see if we can get some better pictures. Okay, I guess this is the best picture they're going to give us. Zoom in a little bit. Now look at that. If you notice right here, here's a native RF connector. This looks like it's a MMCX connector, but its card doesn't have that. However, it does have the solder pads. It's just a matter of rerouting the signal track using components, which is what we're going to have to do. Now, the thing is, I can't get my hands on an MMCX connector, but it just so happens that this entire area over here is the exact same diameter as LMR 195 coax cable. So I could actually hardwire a chunk of coax coming straight from here. So if you can't get your hands on the jack, you can always just go and solder in some coax. Okay, that's as much information as I can really give you on this. Let's go over to the rest of the project, shall we? As to be expected, we've got our two PCM CIA Wi-Fi cards. This one's Mustangs, this one's Kosher Pigs. Some of the tools that we're going to need. Soldering iron? Definitely. Soldering gun? Probably. Of course, you're going to need some kind of PCM CIA Wi-Fi card. You're probably going to need some kind of, like, precision eyeglass screwdrivers to pry open the card. I'm not going to explain how to open the card. Do some Google searches or just pry the damn thing open and hope you don't fuck it up. We're going to need some kind of razor, box cutter, utility knife. We're going to need some wire cutters, big and small. We're going to need some kind of tweezers. Tweezers could be obtained from any pharmacy, from the chick section, from your sister, from your mom, or from your gay dad. Tweezers are going to be needed. We're going to need a small piece of plastic, which I'll explain why a little bit later. I use plexiglass. If you can't get your hands on plexiglass, you can go and get an old piece of Tupperware top or a plastic bin that you put stuff in that you can put under your bed. Just a chunk of plastic from something that will actually hold our radio connector. Our radio connector of choice is a reverse polarity SMA connector that has been successfully crimped with a small length of LMR 100 coax cable. Very, very thin stuff. The reason we're using this is because this card has been modified with LMR 195. It's a lot thicker, which you should understand from previous segments. As to be expected from the internal photos, there is an RF connector right over here, which we are well aware of. And it just so happens that that RF connector is an MMCX, which I couldn't get my hands on. They're hard to get they're hard to get a hold of. So instead of spending $5–10 on connectors, I just directly soldered the coax directly to the board, which you should have already seen in previous segments and will see again in future segments. Okay, with all that said, we have to get to the actual business side of moving components around, as I've previously stated on the FCC's website. So let's go and get a zoom in closer look and see if we can get this done without blowing stuff up. Okay, this is the component right here that's going to be needed to move to here. Now this card, in fact, doesn't have an RF connector of any kind. What needs to be done is we're going to have to go and buff this up over here a little bit, just scratch it up. You can use the tip of a screwdriver, you can use a little buffing wheel, just get it abrased. And we're going to tin this with some solder in a little bit. I'm not going to show you the entire process because I do need to concentrate and I really don't want to have to worry about being in frame. And we're going to tin this pad with some solder so we can come in behind and the signal is going to be soldered to there and the shield is going to be soldered to this metal plate over here. Now, this component is epically small. I mean, epically, oh my god, really? This is going to be difficult. I'm not going to shit you. It is going to be hard. But the bottom line is, with a little bit of perseverance, a little bit of skill, nerves of steel, something I don't have, patience, something I don't have, and a lot of talent, something I, again, don't have, you will be able to get this component off. Now, I'm trying to do this on frame for you guys, but I'm probably going to have to do it off frame. What you do is you heat it up and you just wedge upward a little bit and then using your tweezers try to peel it off, being very careful not to actually break the circuit tracks. Almost. There we go. And it in fact has been removed. Can you guys see that? Yeah, that's really small. You can't see that. But anyway, it's been removed. Now what we're going to do is I'm going to pre-tin this with a little bit of solder. Something I forgot to mention that you're going to need also is solder and desoldering braid. And I'm going to pre-tin this. I'm going to pre-tin this. Got a nice amount of solder on there so you really cannot fuck it up later. And of course you want to pre-tin your RF connector, which I haven't done yet because I really need steady hands. By the way, this is actually being held inside my desk clamp. Not necessary, but for sake of being on camera, I need it. But anyway, I'm going to cut frame, and we're going to go ahead and solder this in place. Okay, there's our component relocated. Now this is our signal track. As I've explained, we've deviated it away from the internal antenna over here onto this solder pad. So now I'm going to go ahead, I'm going to buff the hell out of this and try to tin it with some solder. And try to get the side over here. Now this is actually a really small component. Most of the time the components really aren't this small. That's just vastly epically small. If you don't have very good solder skills, I would definitely suggest you go and get a USB Wi-Fi adapter instead of trying to mod your PCM-CIA. So I'm going to go ahead, see if my solder is going to stick to this, and if it doesn't, I'll go off camera and, yeah, there it goes. Sticks like shit to a blanket. Now I'm going to go ahead and take some solder, just going to try to get this on frame for you, and we're going to try to get a little bit of solder on the center conductor, and we're going to try to tin the shield. Get a nice tin coat on it. I think we're going to have to trim off a little bit of the center conductor of the signal line. Just a little too big for my taste. Now you want to try to get the shield and the signal as close together as possible. You really don't want to have too much of that center exposed. Okay, that's kind of tacked down. I think I cut it a little too short. There we go. There we go. And it's soldered on. Hope you got a good enough angle. Really nothing more I can say about this. It's relatively easy if you have the soldering experience. If you're an absolute beginner to soldering, do not attempt this. Okay, we've got everything soldered in. This one has LMR 195. This one has LMR 100. The problem is these connections are really flimsy. I mean, you got to be really careful, and if you leave this dangling around, you'll eventually break it off. Shit happens. So what I would advise you to do is take a small piece of plastic. This is right here. This is just plexiglass, and I put it in my clamp. You can also use pliers, and I used a butane lighter to heat up the edge, and I bent it at 90 degrees, and then I drilled a hole in which the reverse polarity SMA connector is going to fit. And this is going to be glued to the bottom of the card, of course with the case on, and there you go. Enough said. Gonna go ahead off camera and piece the rest of the card together and show you the final product. Here are our two final products. Here's Mustang's card that has been modified with LMR 200, just sticking out of the side. I would definitely put some plastic reinforcement around this. I just haven't gotten around to it, leading to a nice length, about 5 feet, and then nice end connector. And here's Kosher Pig's card. This one was a little bit more in detail, same process, except now we have a reverse polarity SMA connector. Here's our little plastic piece that's supposed to be glued on, but I haven't gotten around to that yet because I'm lazy. I would not recommend using epoxy. You can, but if you do, plastics tend to be smooth, so go and take some sandpaper and buff both sides of the plastic from the card, from the PCM-CIA card, as well as the plastic bracket. Glue it in place, you're good to go. Keep in mind that this card has been modified. Only one of the antennas are modified, so you can still use this with its built-in internal antenna. Now it's just a matter of actually going out and about, strapping some antennas to these bad boys, and seeing what kind of performance increase they have. However, we're going to leave that for another day because we'll be playing with antennas down the road. So I hope you haven't destroyed anything important and expensive. And if you have any problems, questions, comments, hit us up on IRC. IRC is always the #1 way to reach me personally because it's telepathetically broadcasted directly into my brain. You can hit us up on the forums, definitely hit the show notes, ask questions, and hey, you never know, you might actually be able to pull this one off. Although I'm not going to give you that much credit. Sorry, but I forgot to mention, this little bracket down here, make sure you don't make it too long down the card, because if you put this thing in your laptop and it's too long, it won't fit in. Sorry about that. Keep that in mind.